We've seen how to mathematically find the decision boundary in the binary classification case for logistic regression, the case where there are two classes. Here I want to talk about the other case, which is where there are more than two classes. And in this case, it's going to be three, but everything would be very similar if I was using for a bigger number. Okay, the big difference is between 2 and greater than 2. And I'm going to use the penguins data set. And let me remind myself what the column names are in this data set. So my classes are going to be the 3 classes in the species column. And I'm just going to use 2 of these numerical features, bill length and bill depth. So let me copy those and let me save them in a list called columns or cols. And let me first visualize this data using Altair. So I'm going to use a scatter plot, so mark circle. And then within here, okay, I could type x equals bill length, but maybe it's a little more elegant to say x equals cols 0 and y equals cols 1. Okay, good. And now next I want to zoom in on this data. So by default, Altair includes 0 in these numerical axes, and I don't want it to include that. So let me put Alt X around this. And so far, this changes nothing. That's just like, don't use the abbreviation where you can just instantly give a string. Instead, say I want the X value here. I want that to be some Altair X-axis object. Okay, this is a little object-oriented thing, this capital X here. And then I can add a scale inside the parentheses. So scale equals alt.scale. And again, I haven't changed anything yet. It looks exactly the same. And here's where it's going to change. I'm going to put 0 equals false. And can you predict what's going to change when I do this? Well, are both of these going to change? No, they're not both going to change. Only the x-axis is going to change. So now the x-axis is no longer required to include 0. Okay, and we can do the exact same thing for the y-axis. So let's see. I don't know what the fastest way to do this is. Let me just paste that in here. And now what 2 changes do I need to make? I need to change this x to a y, and I need to say I'm using a different column. Okay, now I'm zoomed in on both the x and y axes. And now let's add the color from the species column. And so I want to talk about if I fit a logistic regression classifier to this data using only these 2 predictors that are shown here, the bill length and the bill depth. Where are the boundaries between, for example, Adelie penguin and chinstrap penguin? Can you expect it to be something like around here, but you don't expect it to be perfect because, like, how would it have this orangish point? How would it have that in the chinstrap class and also have this Adelie point in the Adelie class? I think that'll be difficult with anything that's not like very much overfitting the data. So let's actually check. So first I have to import my logistic regression object or my logistic regression class from scikit-learn. So from sklearn.linearmodel import logistic regression. Okay, good. Now let's instantiate one of these. So CLF equals logistic regression. Okay, so I've imported, I've instantiated. Now let's fit. So clf.fit. And the inputs are going to be just these 2 columns that I saved in that cols variable list. So here I can do df bracket cols. Okay, that'll be a little 2-column data frame. And then I can do df species for my target or my outputs. And let's add a new column to the data frame called lowercase pred for predict. Only reason I'm using lowercase is because most of the column names, or maybe all of the column names in this data frame are lowercase. So I think that's maybe more compatible. So let's say this is clf.predict df calls. And I'm not worried about overfitting here, so I'm not using a training set or a test set. Okay, that's not the point of these videos today. Okay, and then let me copy this. And instead of saying the color is going to come from species, let me say color is going to come from the prediction column. And so it's kind of hard to tell like where the boundary is. Like maybe the boundary is something like an ellipse here. Okay, kind of hard to tell. So what I want to do in the next video is actually like fill in many more points so that it's a whole like filled in grid between this 3260 and this 1322, a whole grid of points. And I want to color all of those. So for example, if there's a point here at 5821, I want to color that using my classifier, okay, using my logistic regression classifier. And when it's like much more denser with points, that's going to give me a much better sense of how the boundaries look between where is Adley predicted and where is Chinstrap predicted.